You know that feeling when you're using an app and it's just buttery smooth? I mean, every tap, every scroll, it just feels instant, almost like magic. Well, it's not magic. The secret behind that amazing experience is a really powerful system called quality of service, or QoS for short. And today, we're going to break down how this one single concept can make the difference between an app you love and one you just delete.
All right, first things first. Let's talk about a problem that I guarantee every single one of us has dealt with. It's that moment, that moment of pure frustration when an app just freezes up.
I mean, you know what I'm talking about, right? You're just scrolling through a feed, maybe you tap a button, and bam, everything on screen just locks up. So you start mashing the screen a few times, hoping something will happen. Nothing. And you start to wonder, is this app just buggy? Is my phone broken? Well, chances are it's neither of those things.
What's really happening here is basically a digital traffic jam. Think about it. Your app is trying to do everything at the exact same time. It's trying to give you a smooth scrolling animation while also downloading new images and maybe processing some data in the background. Without a system to manage all that chaos, the most important task, the one you're actually trying to do, gets stuck in traffic.
So how do you clear up a traffic jam like that? Well, this is exactly where quality of service comes into play. You can think of it as the traffic cop for all your app's tasks, making sure everything keeps flowing nice and smoothly.
When you get right down to it, QoS is really just a way to put a label on every single piece of work your app needs to do. It's like a signal you send to the operating system that says, hey, this thing right here, super important, do it right now. Or maybe, this one can wait. Just get to it later when you have a free second.
And that little priority label, it's what allows the whole system to make really smart decisions. It's not just about what task goes first. It's also about how much CPU power to throw at a task. And here's the really brilliant part. It's constantly balancing performance with energy efficiency. So a high-priority task gets all the juice it needs to be fast, but a low-priority one just sips power, which, you guessed it, keeps the user's phone from dying.
Okay, here's probably the best analogy for this whole thing. Think of QoS as a triage nurse in a hospital emergency room, right? They don't just take patients in the order they walked in the door. No way. They assess how urgent the situation is. Someone with a paper cut can probably wait, but a serious injury? That needs attention right now. QoS is that exact same triage nurse, but for all of your app's tasks.
So if QoS is our triage nurse, how does it actually decide who gets seen first? Well, it uses a set of 4 distinct priority levels, or what we call classes, to sort every single task. Let's go ahead and break these down.
So here we have it, the priority ladder. As you can see, way up at the top, we've got .userInteractive for things that have to happen right now. Then it goes down through .userInitiated and .utility, and all the way at the bottom is .background, which is for stuff the user shouldn't even know is happening. Let's take a closer look at each one of these.
Okay, user-interactive. This is the absolute highest priority. This is for work that is happening literally under the user's finger. So if you're dragging a map around or you're watching a silky smooth animation, that's user-interactive at work. The system will throw every resource it has at these tasks to make sure that user interface never stutters. This is the VIP treatment, the highest level of care.
All right, taking one step down the ladder, we land on user-initiated. This is for when the user has explicitly done something and is now waiting for a result. Think about tapping a button to open an article or load a document. They expect it to be fast, for sure, but it doesn't need to be frame perfect like an animation. There's a little bit of tolerance for maybe a quick loading spinner.
Next up, we've got utility. Now, these are for those longer-running tasks, the kind of thing where the user is aware it's happening. A great example is downloading a big file or maybe processing a video. The user knows it's chugging along, they might even see a progress bar. But the key is they can still do other things in the app while it runs in the background. It's important, yeah, but it's not drop everything urgent.
And finally, at the very bottom of the ladder, we have .background. This is for all the behind-the-scenes housekeeping stuff. We're talking about syncing data with a server, indexing a local database, or maybe preloading some content for later. This kind of work is all about energy efficiency. It runs only when the device has spare resources, and it's designed to have the absolute smallest impact on battery life possible. It is the very definition of out of sight, out of mind.
Okay, so that's all the theory, but how does the developer actually tell the system which priority to use for a certain task? Well, you might be surprised. It's actually pretty straightforward.
So here's a quick peek at what this looks like in actual Swift code.
When a developer needs to run something, they can put it on what's called a dispatch queue. And look, right there, they just specify the QoS class they want. In this example, it's .userInitiated. That one little line of code is the key instruction. That tells the whole operating system exactly how to prioritize this chunk of work. It's a tiny bit of code, but it has a huge impact on how the app feels.
All right, so let's bring this all home. What are the golden rules here? What should every developer keep in mind when using QoS to build an amazing app? Let's boil it down to the essentials.
Okay, here's your checklist. First and foremost, you have to match the QoS class to the job's real importance. Simple, right? Don't label a background sync as interactive. Second, and this is probably the most critical one, never do slow, heavy work with .userInteractive priority. That is a one-way ticket to a frozen, unresponsive app. And finally, always remember the trade-off. Higher QoS means more power and speed, but it also means more battery drain. If you can get that balance just right, you'll have an app that feels incredible and is friendly to the user's battery.
So, I'll leave you with this final thought. The next time you're using any app and something feels just a little bit sluggish or clunky, I want you to ask yourself, is that really a bug? Or is it maybe just a task that got stuck in traffic because it has the wrong priority? Because a lot of the time, a simple QoS tweak is all it takes to turn a frustrating experience into a fantastic one.